Thank you.
Luke, everyone.
Cool. All right, I am super excited. Oh, thank you. Need this. Super excited. This is my first giving a talk ever, so really appreciate getting to be here and being invited. And I hope I do okay. I've been really impressed so far with what everybody's presented, so I'm going to try to live up to that. So the talk is about exploring video editing in the web browser. A little bit about me, what Matt was alluding to. So my name's Luke. I am the founder and CEO of Sequence. Sequence is basically Figma for video editing. So for the past 3 years, I've done nothing but think about how to build a browser-based video editor. And it turns out there are a lot of hard problems to solve when doing that. So I just wanted to share some of the things that came up during that development process and thinking through how you might want to build video editing technologies using browser-based technologies, or when not to use browser-based technologies and go native and how to combine them. So let's rewind a little bit. And for the sake of this presentation, I'm going to refer to a video editor as an NLE, the nonlinear editor. And when we talk about NLEs, like the professional grade ones, there's only a handful of them. There's like Final Cut Pro, Premiere Pro, Avid, DaVinci Resolve. And these are all built by many talented people over many years. And the reason why they're so difficult to build is they have a lot of features. So I'm kind of going to bucket this into like two categories. So on one hand, you have all these features packed into these products. Besides just editing, you have compositing, you have effects, filters, you have library organization, categorizing metadata, all these things. Because when you look at an NLE at the surface level, like there's a ton going on here. So you have all these kind of like just general building a desktop app for a human and making that work challenge. And then on the other hand, you have the kind of video technology challenges that we're all familiar with here. Video is really hard. You have the container formats, you have the codec formats. You have to make sure that all of these things play nicely on both sides of whether, what you're spitting out and what you're taking in. And so this whole problem space of, okay, all the human interface challenges of how do we tell stories with video, mapping that into controls, building that into software, and then making that software actually control all of these different video pieces of technology is a really big problem space. And then if you try to do it with technology that was originally designed for rendering hypertext markup documents over a network, this becomes a lot harder. And so 3 years ago, I asked myself, okay, every creativity and productivity tool is moving to the web. What web technologies exist today that are going to let us take an NLE from the desktop and actually run it in the browser? And so going back to these two challenges, the first thing that I started to look at is okay, well, you have all these kind of app challenges to make this user experience work. And for the sake of this talk, we're actually not going to talk about them because that could be its own talk. But just in case you're curious, these are some of the things that you might face with just trying to build a desktop class application in the web browser. In particular, one of the things that I will bring up that's complicated with the browser, which originally started like a JavaScript context is normally single-threaded. There's now web workers that you can use to have multi-threading. But one of the challenge things with just getting like a really high-performance, fast application running in the browser is just not blocking your UI thread, because you have basically one thread that's doing the UI and a lot of your business logic. So that's one thing to keep in mind, that as you're getting into solving the video player technologies, that you can't block that one thread that's kind of doing a lot of these things. So orchestrating that is a difficult and just kind of a traditional browser problem. So moving on to the video challenges, I kind of bucket these into three categories. So you have one, the nonlinear media playback, actually taking clip A and playing it from maybe 2 seconds to 5 seconds, and then taking clip B and playing it from 10 seconds to 12 seconds, stacking those back to back. And then maybe you're going to want to apply some filters or effects when you're actually playing those clips back. And then you're probably going to have multiple layers of these audio and video, and you're going to need to composite or mix them together. So diving into browser technologies for nonlinear media playback, there's a couple different approaches I've seen different browser-based video editors use. To start, you might try to build a video editor just using your basic HTML DOM elements. You might try to use a video, an element, and then you might try to, maybe then you get into the compositing, you might use some SVGs, and you're going to try to like composite everything in the DOM. The interesting thing about using the video element is the current time method is not quite accurate enough to identify individual frames. And so this can become a problem if you're a pro video editor and you need to get this frame accurate video decoding. So then you might consider using WebAssembly, and there's a lot of really cool libraries for that. We have ffmpeg.webassembly, tinyh264. This is a really, really cool approach I've seen where people will spawn another worker thread, load up some WebAssembly, and then actually use that to decode the video. And you can get really good frame accurate seeking, but it's super heavy on your CPU if you're doing this in software. Which leads us to WebCodecs. And so this is currently like kind of the best path forward. I'm sure a lot of people have talked about this at this conference already. But WebCodecs is really great because it offers us the ability to do frame accurate seeking, as well as take advantage of the hardware acceleration existing on whatever device. But kind of going forward a little bit further, the browser was kind of designed with this intention to use delivery codecs. So we have great support for H.264, H.265. Video editors are really used to working in higher fidelity formats that are great for editing, things like ProRes or DNX, these intermediate formats that have intra-frame compression, so you can randomly access each frame, which is really, really great if you're trying to like seek through a timeline and just jump to the particular part that you want to play. You don't have to do the kind of, you go back to your iframe and then decode ahead. So the promise of WebCodecs was kind of that eventually we'd be able to maybe ship our own decoders for using WebAssembly or WebGPU. The spec has not implemented that yet, so that a application can ship its own decoder, but really provides the browser engine for a way to expose the decoders that exist on its system. So I think one of the things that what we need is a broader support for intermediate codec decoding within the web browser, I think, to kind of take this to the next level. The next part, effects, filters. I think the main thing when thinking about how do I want to apply a look or something to my video or other visual elements in the browser is really thinking about the browser paint order and actually how the browser is taking, okay, it's got this bit of text, it's got this bitmap, it's got this video. How does it actually paint all these things, and what are the CSS properties? What are the ways that you can actually manipulate this, and what is done on the GPU and what is done on the CPU, what order, what is being copied back and forth. The browser, as it evolved over time, just gained more and more APIs. And so I've found that this is one of the challenges with just shipping a high-performance browser application is really thinking through the steps that the browser goes through to actually get some pixel on the screen and what that journey is. So bunch of different methods here, but there's hardware acceleration and CSS filters. There's WebGL, WebGPU now, which just got launched. This can be really, really efficient if you're keeping all of the textures in the GPU memory. But you can also use WebAssembly, and with SIMD, there's can be helpful, faster processing. And I think the main thing is just thinking about these copies. And if you are using WebAssembly, making sure that you might be using like a shared array buffer, so you can actually share memory between the threads to, again, reduce this overhead that occurs. Compositing and mixing. Kind of touched on this a little bit before. One of the ways that you might start out building a browser-based video editor is just relying on the HTML DOM and just using the standard elements, using markup to actually construct your video player. This can allow you to really, really quickly hit the ground running because you automatically have text, you have images, you have video. And then if you're careful about how you use the CSS properties, you can get really, really good performance out of the box. But if you need to take it a step further, you're going to have to dip into WebGL and WebGPU in order to break through the performance limits that are just naturally there because of how the browser renders. And again, WebCodecs is useful here. You can actually keep your video buffer on the GPU memory and then pass it into that context without having to copy it. So I'm kind of talking about a bunch of different problems with building a browser-based video editor. And this kind of led me to the solution that we've used at Sequence, and I've seen and a couple other places, and that is actually using the server for server-side rendering video. And this is interesting because it avoids some of the bottlenecks by leveraging native code, system-level kind of languages like Rust, C, to do multi-threading in a much more efficient way than you can do in the browser and take advantage of hardware acceleration of much powerful GPUs on a server. And then you can use streaming things like HLS- or WebRTC to actually stream back your video with low latency or ultra low latency. And this is interesting. There's trade-offs in this approach. It can be really expensive to do video rendering on the server, but you can also scale that processing power to whatever size project you need. You can take advantage of intermediate and raw decoders that are available on the server and not in the browser. But then you also run into issues with like synchronizing state between your client and server. So other considerations, your video player is probably going to have other things like thumbnails. It's going to have maybe assets that you are serving directly through the client. Thinking through how a user is actually going to interact with this and fetching that data in a timely way, prefetching it, not blocking that main UI thread is really important. So, it's tough to build a video editor in the web browser. I'm happy to answer some more questions you guys might have about it and just chat about the experience, and happy to talk to anybody after as well. Thank you.